One of the last big ideas that we normally teach in Unit 1, but in my case I moved it as the start of Unit 2, is this idea of instantaneous rate of change. Up until this point in your math education, we've always talked about average rate of change. Given a point in time and a second point in time, we look to see how is some particular thing changing on that time interval. Now, thanks to calculus, we can actually talk about the rate of change at an instant. So, for example, I've got this function over here. Doesn't really matter what it represents. It's a function. I want to know how is the function changing at this one exact moment in time. I can see from the graph that the graph is increasing. And so I would expect that if at this point over here, the slope of the tangent line is going to be positive. We looked at that in the last video. And what we want to be able to do is we want to find that exact point. I'm sorry, not that point. We want to find how is it changing. We want to use appropriate vocabulary to describe that change. And we want to use good notation to communicate what we're measuring and what the units are. So, because we are in calculus class, because we are talking about how things change, well, the setup is going to be the same. In order to find the instantaneous rate of change, what we need is the derivative. So we're going to find f prime of a, which is our favorite formula. The limit as x approaches a of f of x minus f of a over x minus a. Other notations that we're going to use, we might say find f prime of x and evaluate it at x equals a. We might say find y prime and evaluate it at x equals a. We might say find dy over dx evaluated at x equals a. And it may not always be y and x. It could be w and t. It could be c and g. But no matter what we're doing, let's say that we found out that dy over dx is equal to -3, or dy dx evaluated at x equals 6 equals -3. The sentence we're going to write is going to be something to this effect. When x equals 6, the y value is changing. Well, how is it changing? If dy over dx, if the instantaneous rate of change at 6 is -3, we'd say when x equals 6, the y value is decreasing by 3 blank per blank. Blank per blank. And the blanks are going to be filled in by whatever the units are. We're going to do an application problem. Whatever the units are for the numerator is going to go over here. Whatever the units are for the denominator is going to go over here. But the flow of the sentence always is going to be when x equals 6, the y value, the numerator, is either increasing or decreasing, depending on the sign, by whatever the rate is, blank per blank. So let's actually do, let's look at a problem. So in this function, we're given a function g of v is fuel efficiency measured in miles per gallon of a car going at v miles per hour. According to the researchers, the function g of v, shown below, can be used to relate the speed of the car. So we're connecting the speed of the car to the fuel efficiency of the car. And we have this piecewise function down here that does all of that. So the first thing we're asked is to explain the meaning of dg dv. We have this notation, dg dv, evaluated at v equals 27. Well, if I'm going to explain that, I'm going to say when v equals 27. Well, what was v? V was the speed of the car. And what's that being measured in? Well, that is being measured in miles per hour. So when the velocity of the car is 27 miles per hour, the g, what's the g? The g is the fuel efficiency. The fuel efficiency of the car is, well, what's it doing? We don't know exactly what it is. We weren't given a number. If it's a positive number, we would say it's increasing. If this is a negative number, we'd say it's decreasing. So we're just going to say is changing at a rate of, we don't really know what it is. Okay? What are the units here? The units are going to be tricky. At a rate of units for G, we said is miles per gallon over, okay, miles per gallon are the units for G. Units for velocity is miles per hour. So the interpretation would be, when the velocity is 27 miles per hour, the fuel efficiency of the car is changing at a rate of blank, whatever it is, miles per gallon per miles per hour. Don't worry too much about, the ugliness of the units. These are the exact right units for this problem. So now that that's done, let's move on to part B. In part B, we're asked to compare the fuel efficiency of a car traveling 27 miles per hour to that of a car traveling 50 miles per hour. Well, the fuel efficiency of a car traveling 27 miles per hour, if V is equal to 27, I need to figure out which piece of the piecewise function do I want. The velocity is between 0 and 40. I want this one. It'll be negative square root of 27 plus 9 plus 32. We get negative square root of 36 plus 32. Square root of 36 is 6. Make it negative plus 32, 26. The fuel efficiency, G of 27, of a car traveling 27 miles per hour will be 26 miles per gallon. Okay, well, let's check on the fuel efficiency of a car traveling 50 miles per hour. Fuel efficiency of a car traveling 50 miles per hour, we use the other equation now because the velocity we're looking at, we're greater than or equal to 40. It'll be negative 50 minus 40 squared plus 25. 50 minus 40 is 10. 10 squared is 100. So we're going to get negative 100 plus 25, negative 75 miles per gallon. That's unfortunate. I picked a bad problem here. So let's just pretend that a negative mile per gallon is okay. Clearly it's not. But for the sake of this problem, the problem is good. The function I selected was bad. Okay. So that's part B. Wah wah. All right. Part C in this problem asks you to determine the value of G prime of 27 and G prime of 50. Since we know 50 is going to be a problem, let's just find G prime of 27. G prime of 27, let me fold my paper up. G prime of 27 is just the derivative evaluated at 27. So I need how G changes over how V changes when the velocity is equal to 27. Well, we have a formula for that. That's going to be, what's the limit as V approaches 27? G of V minus G of 27 over V minus 27. Because my velocity is getting closer to 27, I'm still in this first piece. So we're going to get that it's the limit as V approaches 27. G of V is negative square root V plus 9 plus 32 minus G of 27. We already figured that out earlier, was going to be G of 27 is 26 over V minus 27. We get the limit as V approaches 27, negative square root V plus 9, 32 minus 26 plus 6. over v minus 27. If I take the limit as v approaches 27, we're going to get 0 in the numerator, 0 in the denominator. Uh-oh! Need some algebra trickery. Get that square root showing up again. We're going to multiply by the conjugate. We take the limit as v approaches 27. Negative square root v plus 9 plus 6. We need to multiply by the conjugate. The conjugate will be negative square root v plus 9 minus 6. In the denominator, negative square root v plus 9 minus 6. We're going to multiply numerator with numerator, denominator with denominator. When I do that, we get the limit as v approaches 27. Negative square root of v plus 9 times negative square root of v plus 9 is just v plus 9. We already talked earlier, when I multiply the first term and the last term and combine it with the last term times the first term, those cancel out. And then we have 6 times negative 6, negative 36. Denominator v minus 27 over negative square root v plus 9 minus 6. Let's save ourselves a little headache here. V plus 9 minus 36 is the same as v minus 27. These two expressions will cancel out, leaving us limit v approaches 27, 1 over negative the square root of v plus 9 minus 6. If I plug in the v now, I get negative square root of 36 minus 6, which is 1 over negative 12, negative 1/12. What the heck does that mean? G prime of 27 equals negative 1/12. Let's write that in the proper sentence. We would say, when the velocity of the car is 27 miles per hour, right? When v equals 27, the G, the fuel efficiency of the car, well, we know it's changing. How is it changing? Negative. It's decreasing by 1/12. Units for G are gallons per hour per, so gallons per hour per miles per hour. So one more time. When the velocity of the car is 27 miles per hour, the fuel efficiency of the car is decreasing by 1/12 gallons per hour per miles per hour. Something's wrong. Miles per gallon, that's the unit over here. G is measured in miles per gallon. And the V is measured in miles per hour. Well, that just ended badly. That's just a hot mess. Okay. When the velocity of the car is 27 miles per hour, the fuel efficiency of the car is decreasing by 1/12 miles per gallon per miles per hour. All right. Done with that video.